9.2 is simplifying square roots. When you have square roots, we always want them in the simplest form. Okay? We're going to talk about simplest form, then I'll come back to this. Simplest form requires two things. One is that no factor of the expression under the radical sign has any perfect square root other than 1. So if the number is 16 under it, that's not simplest form because it has a perfect square. Okay? If the number is 9 underneath, that's not in simplest form yet because it has a perfect square. If it's 3 under the square root sign, it's fine because that doesn't have a perfect square. Okay? The other rule is there are no fractions under the radical sign. And no radical sign in the denominator spot. I cannot have a radical in the denominator spot. Which means if it's not a perfect square in the denominator spot, I got to get rid of it. We'll talk about that later. Today, they'll all be perfect squares that we're working with. Okay? Product property. What's product mean? Multiply. It means I'm multiplying stuff. Okay? The product property. I want you guys to do something with me real quick. If I take the product property and I take radical 4 times radical 16, okay, what do I end up getting? What is radical 4? 2. And what is radical 16?
4.
So what do I end up getting? 8. Okay, that's my answer. Now look, if I have this both under the same radical, the square root of 4 times 16, what do I end up getting?
64.
It's what? Okay, it's 64. You get 8. Because radical 4 is still 2, and radical 16 is still 4, and 2 times 4 is still 8. Okay? Or, yeah, so when I multiply them. So what happens is, sometimes we're going to use this product property, and the number on the inside, such as 180, that's hard to know what the radical is. It might not even have a perfect square. But if I can break it down into two separate factors, I can take the radical of one of them and then figure out from there. Yes? Marshall, we don't have time for this. So, that's what we're going to look at. Does that make sense? Okay. So, let's talk about simplifying radical 180. Okay? What do you know about the number 180? It's even. What can go into it? Do you know
90.
a perfect square of 180?
90.
No. That's times 2. We don't know a perfect square. But do we know any perfect square that can go into 180? Think about 180. If I take 10 into it, if I take 5, you can take 5 into it, right? You can take 2 into it. What do you do when you take, let's just work with some numbers here. I like to do something called a factor tree, okay? And that's where I'm going to take 180, and I'm going to see what factors can go into it. What'd you say?
2 and 90.
2 and 90? Okay. 2 and 90 can go into it. What goes into 90?
30 and 2.
30 and 2. Okay.
15.
2 and 15. Okay.
No, that's wrong.
Yeah,
That's wrong. It's 45 times 2.
it is 45 times 2. And what goes into 45?
9 and 5.
9 and 5. Okay, so look at this. Okay.
30.
So what I did is this. I broke it down into some other numbers, right? Which is what they're doing over here when they break this number down, okay? So what we can say is this. We have 2 times 2 times 9 times 5, right? Okay.
Didn't you break 9 down to 3 and 3?
Well, yeah, we'll get there in a second. Give me a second. I can break 9 down into 3 and 3. So if I go with all the prime numbers, okay, here's how this works. I can make a factor tree and I can go with all the prime numbers, okay? Because you always want to break down to all prime numbers in factor tree. 2's prime, 2's prime, 3's prime, 3's prime, 5's prime, okay? When you are taking the square root of something, square root is like when something is squared, right? So how many of them are there? 2. So I'm looking for groups of 2, okay? Here's a group of 2, here's a group of 2. Now, When I'm taking them out of the square root, okay, they become 1. Meaning, I only have 1, 2 here, and I only have 1, 3 here, okay? So on the outside, I have like 2 times 3, and then 5 stays inside because there was no pair, so it's all alone, okay? So on the outside, I end up getting what? 6 radical 5. This is the simplest form, okay? They want you to be able to do this on the inside. If I have 6 radical 5, that means that I know 180 can be broken down into 36 times 5. Do that on your calculator. What's 36 times 5? Double check.
How did we
180.
get 36?
I'll explain in just a second. So technically in here, I can break it down into this so that I see a perfect square. Okay? I am not good at doing this right here. I'm very good at doing this. Okay? If you need to do this first. Okay? The way I knew that it was 36 times 5 is because my final answer was 6 radical 5, which means I took the square root of 36 to get 6 outside of there. Do you get what I'm saying? Okay. When I do the factor tree, I had a group of 2 and a group of 3, which gives me 6. But technically, that meant that I had 36 times 5 for 180. Because what's the square root of 36? 6. So if you were able to recognize that 180 had multiples of 5 and 36 first, you could have saved yourself time and just said, oh, it's 6 radical 5. Does that make sense? Okay. If you can't recognize that yet, make a factor tree and get your group set up. Okay. Let's look at this one, because this one has variables with it. Okay. Let's treat each thing individually. We're going to treat the number individually and the variable individually. Okay. So 24. Does 24 have a perfect square? No. But what do you know are multiples of 24? Anything with a perfect square?
6.
Okay, 6, but is that a perfect square?
8.
What did you say,
12.
Emmanuel?
2 and 12.
No. 4 and
6.
No.
time out. 4 times what gives me 12?
3.
3. So underneath, I can break this down to say 4 times 3 times s squared. Yes? Okay. 24, sorry. We're doing 24, we're not doing 12.
Yeah.
Okay.
So 2 and
6 and 4.
No. Stop. What did you say?
6 and 4.
6 and 4, because 4 is a perfect square. So 6 times 4 times s squared, right? Okay. 6 isn't a perfect square, so it's going to stay inside. 4 has a perfect square of what? 2. So 2 comes out, 6 stays inside. What's the perfect square of s squared?
S.
So my answer is 2s radical 6.
Why do we put the S on the outside?
Because when you have s squared, that means you have s times s, right? Is that a group of 2?
Yes.
Yes, so it comes outside.
So any group of 2 goes to the outside.
To the outside, correct. And they're multiplied together on the outside. That's why it says 2s. Does that make sense? Okay? Okay, so let's look at the quotient property. Quotient property means there's division going on. And there's division going on inside of my radical. We do not like division inside of a radical. Okay? For 2 reasons. 1, that means that my denominator cannot be what number?
1.
No. What number can never be in your denominator spot?
0.
0. Okay? So I cannot have a denominator of 0 or else this problem's invalid. It doesn't work. Okay? And I don't like having radicals in my denominator because they cannot be there because that's one of my rules. No fractions on the under the radical sign, no radical sign in the denominator. Okay? So if I have a fraction, this one's algebra, like with letters, this one's numbers, okay? If I have radical A over B, I can break it up to say radical A and take that square root divided by the square root of the bottom part. So I'm just doing the square root twice, okay? I'm breaking it up so I take the square root of the top and the square root of the bottom separately. I'm not taking the square root of the fraction. You are not plugging in your calculator the square root of 11 over 4 and getting a decimal answer. you are going to separate it out so that it says the square root of 11 over the square root of 4. So your answer becomes the square root of 11, because there isn't one, over 2. I don't want a decimal answer. Unless your book says plug it in your calculator and round your answer. That's the only time you're going to give me one. When we are working with quotient property, I want it to still have a radical in it if it's not a perfect square. Does that make sense? Okay. So this meets this requirement because there is no fraction under the radical sign that's left. Okay? And there is no radical in the denominator spot. So then we're going to do 5 problems of simplifying. And then we have a word problem. Okay. Radical 13 over radical 36. How do I have to break that down first?
You have to take the square root of 36.
Over the square root of. Now, does 13 have a square root?
It would be 13 over 6.
It'd be radical 13 over 6. Okay?
And
that's your answer.
Yeah, that's your answer. That's as far as you can go.
That's it.
That's it.
So all you're doing is
Okay? How do I take the square root of 63? Think about 63. What numbers go into 63?
9 and 7.
9 and what?
7.
7. Beautiful.
7.
So I changed this to the square root of 9 times 7. Do any of those have a perfect square?
Yes.
Which one?
9.
So you take a 3 out and you're left with what?
7.
3 radical 7. Your answers on your homework are going to be left in radical form. Do not give me decimals. I will stress that again. Do not give me decimals. Leave it in radical form.
How are you even supposed to get decimals out of that?
Well, if you plug it in your calculator, you're going to get decimals.
The square root of 63 is another.
Yeah, because it's not a perfect square. So I will know if you actually did homework or if you plugged it into your calculator. Get what I'm saying? Okay. How do I set this up? Radical 15 over 16.
You take the square root of 15 over the square root.
Okay, square root of 15 over the square root of 16. Does 15 have a square root?
No.
No, and I can't take any groups out of it, right? Because it's just 3 and 5.
And then 16 is the square root of
4.
And then 16 is the square root of 4. So see how I said on your homework they're going to give you square roots in the bottom that are perfect to help you out right now? Because later on it's going to get messy. Okay. How do I do radical 32 over n squared?
You take the
Radical 32 over radical n squared. Now,
I thought there couldn't be any radicals in there.
we're not done. Now, 32, what does it break down to? 8 and 4. Do one of those have a perfect square? 4. So you have this up top, you have this on bottom, right? So 4 breaks down into a perfect square of 2. So you get 2 radical 8, right?
Yeah.
Over, what's the square root of n squared?
And
N. And there's your answer. Okay? 54t squared. Can I break 54 down into anything?
9 and 6.
9 and 6. Beautiful. 9 times 6, t squared. Okay, square root of 9 is?
3.
Does t squared have a square root?
T.
T, and then I have 6 left. That's how I write that answer. 3t radical 6. Okay? So break everything down into multiples that have perfect squares. That's what we're looking for. Okay? It will save you time. It will be much quicker than going through and making that factor tree every time. Cool? Now, word problem. After a car accident, a police officer measures the length, L, in feet of a car's skid marks. The expression radical 27L gives the car's speed in miles per hour at the time the brakes were applied. Write the expression in simplest form. How do I write radical 27L in simplest form? What did you say, Kate? 3 times 9. So this is radical 3 times 9 times L. So what does that turn into? Radical 3L. Okay, there's the simplest form. That's what they want for A. Now B says the skid marks are 120 feet long. Use the simplified expression, what we just did, to approximate the car's speed when the brakes were applied. So what do I do? Okay, now here's the deal. Does 125 have a perfect square?
Yes.
5 or something.
No, but does 125 break down for me so I can find perfect squares? Of what? Is it 25 and 5?
Yes, 25 and 5.
Okay, 25 and 5. So I'm going to break this down to say 3, radical 3 times 5 times 25. So what comes out of there? A 5. And I do 5 times 3 on the outside, which is?
15.
And I get 15 radical
3
times.
5.
So 15 radical 15 is my answer? Yes. Yes. Because I took the square root of 5, or the square root of 25, which is 5, and I multiplied it to the outside, right? To get that 15. And then these just get multiplied back together on the inside because there's nothing I can do with them. Okay? So 15 radical 15, and it should be, what is it, like, is it miles per hour? What's the time the brakes were from? Yeah, because it says approximate the car's speed, miles per hour. Okay? So you can leave it in that form for your answer. Yes? Yes. So the two numbers on the, whatever you have on the outside, you always multiply together. And whatever you have on the inside, when it's in simplest form, you just multiply it back together. Okay? That is what you are doing for your homework. Let me give it to you.